Hi everybody, in this demonstration I'm going to use Terraform to add a Azure Container Registry and a Key Vault to an existing AKS infrastructure. We're going to use the Key Vault to encrypt the container registry and restrict access to the Key Vault by making use of private endpoint. Let's take a look at the start scenario in our case, because like I said, we're going to add a container registry and a Key Vault to an existing infrastructure. And the business case here might just be that, say, our consultant colleagues did a proof of concept for a client. They already set up an AKS cluster, some database for storage or for data persistence, and a storage account for logs and whatnot, plus VNet and some stuff. And they just showed that the client application can work in a cloud environment. They've done that. And now maybe the client decided to go forward with the project. And now it's our turn as cloud engineers, say, to bring that infrastructure closer to what is required when we're heading towards production, which means real data that has to be protected, sensitive data. So it might have already been us who implemented private endpoints for the past resources that are already in play here. We are going to do that again for the Key Vault. And that's where we will set up our additional resources on top of. Okay, let's also take a look at what we are going to have by the end of this video in the Azure portal. I'm using the resource visualizer here that you have in every resource group. And for this specific demo, I've put everything into one resource group just to have all the resources together here. But having said that, keep in mind the resource visualizer doesn't actually show all resources. For instance, it doesn't show subnets. There are some not displayed here. It doesn't show role assignments, very important, and diagnostic settings and other things too. But we do get an overview of the end result. And like I said, we are going to extend an existing infrastructure with a container registry and a key vault, and the resources already in place are an AKS cluster. For ease of use, it's not a private cluster here, just a standard AKS cluster which writes logs to a log analytic workspace. It has a user-assigned identity to interact with the container registry, as we're going to see. It would use an external database service, external meaning external to the cluster for its state, for its data, which is a MySQL server in our case here. And like other resources, it is integrated into our VNet via a private endpoint, which is basically always required in professional setups. So we see the private endpoint itself, the NIC, the network interface card that actually holds the IP address from your VNet. A private DNS zone is required for a private endpoint connection, and the resource not shown here is the CNAME record, which is also in place. The VNet has a network security group, and to reference the database instance, it has an application security group for the database, a storage account, for instance, for audit logs of various services, and of course, the key vault that we're going to create, also private endpoint integrated. As we come over to Visual Studio Code, let me quickly show you what setup I'm using, what versions I'm using for the Azure RM provider. I'm currently using this version here. It's not the latest at the moment, but it's the one that works with everything that I want to do. And yeah, very important overall. Had it multiple times that I wanted to use some feature that I found in the documentation that just didn't work, and it was because of a lower Azure RM version. Then my Terraform backend, meaning the state file, is in a storage account. You basically have to do it that way once you start working together as a team, because then others can easily use the state file. Don't push your state file to the version controller, I'd say. That will most certainly lead to chaos. And the Azure Blob service, by the way, this last line here, it's called key, but it's just referencing the blob that holds the state file. It has a very nice feature where it locks your state file once somebody runs Terraform apply. Very helpful to prevent collision with somebody else trying to change something while you're on it. So always do that. And then I've already put something in the features block that, yeah, most times it's empty, but here we actually have some Key Vault features that we can put in here. I've set both to false here. The Key Vault, as you know, is anyway soft delete enabled by default. I don't want to purge anything when I run Terraform destroy. Plus, I have purge protection enabled because that is something usually something that your company wants you to do anyway. So no chance to purge anything on Terraform destroy. Plus, yeah, I don't want Terraform to recover soft deleted keys. As we are going to see, our key won't get deleted anyway when you're running Terraform destroy. And if it does happen that you somehow accidentally delete a key, then you can always restore it in the portal, but it's not going to happen in our Terraform setup anyway. So that's also set to false. Next section, at the moment, as I'm approaching a setup that is production ready, but it's not yet production ready, I'm using a service principal that I used to run Terraform locally, let's say from my machine. And the service principal has an ID and a secret, and I put these into environment variables. First of all, to not store them in code would be bad practice, could be pushed to version control. You don't want that. Plus, obviously, when I'm still developing and starting Terraform over and over, I don't always want to paste these in or whatnot. I could have them in a local secret manager and paste them in, but I have them in environment variables. And this is what this block is for, that Terraform use that specific service principal that also has the appropriate rights to run these commands. Regarding the project structure, you can see here that I have a module more or less for every major component the infrastructure is going to use. I probably overdone it a bit. User-assigned identities certainly don't need their own module. When we are creating the Azure Container Registry, for which I already have these 3 files that I have in every module, we're going to put the managed identity within the ACR module, as well as the components from the public endpoint and the role assignment needed, so that everything that is needed to make the Azure Container Registry work is within this one module. And when we've done that, the modules get referenced in the project main file in these module blocks here, which we are taking a look at, obviously, once we're done within our independent modules. Since the AKS cluster is such an important component and does interact with our container registry, we quickly have a look at the already written out configuration for the AKS cluster, and I just want to point out certain aspects that might be important here. First of all, it's a CNN network type of cluster. You can see that in the network profile block here where it says network plugin Azure. Then we definitely need role-based access control enabled because it's going to use a role assignment to pull images from the container registry. And then one more thing that I wanted to mention regarding the compliance and security aspects of it. Right now, the cluster isn't a private cluster. It's still a public cluster, but I at least have restricted the access to the control plane or API server, as it's called, to my private IP address. One of the two you probably already want to have in place while you're developing. And then once we're going into production, the cluster probably becomes private in most cases. And the build agent or runner, as it is called in GitLab, will most likely sit within your VNet and interact with the cluster via that private connection and doesn't need to go over the public internet. Okay, let's start with the Azure Container Registry and its configuration. Let me close the, I know it already was the main file for the ACR. Some introduction up here. We need the premium SKU in order to encrypt it via a custom range key, a very popular requirement of companies in terms of security. Plus, if you need geo-replication, you also need the premium SKU. But yeah, encryption alone is often enough to require that. So that's what we're going to do. To get the key for the encryption from the key vault that we're going to use to do later, we need a user-assigned identity. And I already prepared some code here just to make it quicker. Everything that is pretty much standard is already there. And for the user-assigned identity, that's already it. Nothing complicated to it. It just has a name that you choose. Remember, this name up here is the one that we are going to reference in the other resources. And this one is the name that is going to show up in the, say, portal when you're looking at it. So yeah, choose whatever you like. Then, of course, it needs a resource group. And I already have the resource group set in the project, like I said in the introduction, in this project for better overview of things. I've put everything into one resource group, but whatever, could be another one resource group, ACR or whatever. And the location is already used in the project, so there's already a variable dealing with location and resource group, of course. And that's it for the managed identity. Next is the actual container registry. I just named it that TF demo ACR, and here the actually name does matter a bit because it has to be globally unique, like you know it from your storage account and certainly other Azure resources as well. So if you're doing something like Terraform demo ACR, you probably need a random string. I have one, resource group and location. And now the first thing is that we have to set the SKU. Since I have the Terraform extension, it is called here, right? Yes, I can just hit Control Space and see everything that is available. In that case, it's not very hard. It is SKU, stock keying unit. And here we use premium. I think capital letter in the beginning matters. So we do that, premium. By the way, if you want to avoid formatting, just right click, format document, bam. Then we have an identity block since we're using the user assigned identity. We specify the type here, or let me try auto completion. Is it there? It is there. Type first, it is user assigned. It's a string, goes in quotes. And then we already sort the identity IDs, and that's a little specialty here that it has to be a string. Sorry, a list. It's a list because you could provide more. Okay, we don't want a individual string value, but we want to reference our user assigned identity that we defined up here. So we do that. Azure RM user assigned identity dot, and then it should provide us the ACR UA1. Doesn't. Okay. It sometimes doesn't work, I think, depending on how you break the line, whether you move down a line using the arrow keys or using the return key. Okay, but that is pretty much what we want here. Next is the encryption block. It already is suggesting a object here. We can take that and it already gives us the free components, that the free parameter that we need. I'm only pretty sure that we don't want these square brackets up here. It should like the identity block above. Maybe it doesn't matter. I just erased them. I'm pretty sure it works. Enabled should be true in our case. Identity client ID is the ID of the user assigned identity that we created above. So we are going to reference that. ACR, UAI, and then the client ID. There it is. And the key vault key ID, the key that should be used to encrypt, that we obviously don't know yet. I have to make a variable for that and pass the actual value in the main project module later on. So we're just using a variable here and construct a variable later on. Okay, that's it for the encryption block. We could think about a depends on block, that this container registry should depend on the Azure role assignment, because the user assigned identity above here needs a role assignment, crypto user or higher, to access the key vault and get a key out of it. But usually a depends on block, I'd say in my experience, is not necessary. It usually works out quite nicely when Terraform does it on its own. Within the role assignment resource, you can choose whether you want a ID or a name. And I personally thought ID is always better. And I thought from the documentation, I would just pick that long string of random numbers and characters that looks like a subscription ID. I can show what I mean here. But actually, you don't. When you're going for the ID, you need the whole subscription with its ID and the Microsoft authorization provider, and then in the end, the actual role ID. I'm gonna paste it in here because it's a really long string that I had to build basically using my subscription ID, and then the role definition ID in the end. You could as well go for the name for the string, and that works perfectly fine as well. I just wanted to show that way here because I find it very counterintuitive and I didn't find it all too well documented. So here you go. Providing the role definition ID like this works. Okay, the principal ID, to which identity this role should be assigned. Obviously, that is our user assigned identity that we created. And from this object, we need the principal ID. In that case, it should be this one. Yes, right. Okay, and lastly, the scope. Where should that apply to? And let's say it should only apply to our key vault. So we use a variable that is referencing our key vault, not the key as we did above, but the key vault. Let's format it. Okay, nice. Save it, and done as far as the container registry goes. Let me show you the outputs file that you have seen that as well. I output the ID from the user assigned identity from the resource itself, and in the value I specify that, plus short description, the client ID from the user assigned identity, and the ID of the actual container registry. In the variables file, I have some basics like the location and the resource group. And like I said, only for demo purposes, I've put everything into one resource group here. In the real world, you probably want your container registry and other resources in their separate resource group. That's why I have one here, but it's not used, commented out. The project name could be used for naming things. We didn't do that here. Wrote out or hard coded the global unique name like that, but otherwise we'll do in the key vault that we use the project name in the name from the key vault. The key vault ID for the role assignment and the key ID for the encryption block of the ACR. Okay, now to the more complex part of the key vault. I prepared something here as well. We want a key vault with RBAC authorization enabled, role-based access control. We want a key for our container registry to encrypt the images that we store in there. And we want private endpoint enabled to allow for private access just through our own virtual network and not via the private endpoint, the public endpoint, the public IP of the PaaS service key vault. And we certainly have to log everything regarding the key vault, how it's being accessed, what has been accessed. And for that, we are providing diagnostic settings as a resource here, which is basically a cheaper alternative to the log analytics workspace that you would use for all these analytics features. If you really want to dig deep into flows within your application in the AKS cluster, there we have it. There's a log analytics works enabled, but for key vault, where it is mainly auditing, I'd say writing logs in a storage account is good enough. Okay, let's start with the actual key vault and its name within our configuration, the display name, so to say. We can choose that obviously, and I'm using the project name here from within a variable plus a key vault abbreviation. It has the standard location. It needs the tenant ID from our Azure AD tenant and obviously a resource group. Okay, and after that, there are quite a lot of features that can be enabled or disabled. Let's start with RBAC authorization. That, as I said before, is something that we definitely want because it should be possible to use role assignments with the key vault. The alternative to that is so-called access policies, where you specify per client ID that should be allowed to use the key vault what rights it should have on a level for the keys, secrets, and certificates. And we are basically doing the same without all that specification by using fine-grained roles, and we can use the built-in roles. We don't need to write custom roles here, like the crypto user that you already assigned to the identity of the container registry. Next thing that can be enabled or disabled is disk encryption. I don't want it here just because right now I don't have a VM. If you later have a build agent or GitLab runner in the project, that, yeah, definitely would be good to have to automate the release pipeline or, yeah, to automatically deploy our infrastructure. Then, yeah, we might use it to encrypt the disk from that build agent. On the other hand, if it lives within the VNet and the VNet is restricted and it's only a build agent, I don't know if it's really that necessary, but we could switch that to true here. Next thing is template deployment, which basically means that we want the key vault to be able to accept ARM, Azure Resource Manager commands, and we definitely want that. Then one other thing that is often requested or needed in terms of security standards is purge protection. That is something that we want to set to true. Oh, it's purge protection enabled, let's say, so that it is, yeah, not possible to purge, to delete the whole key vault. In any case, we can set a, is it giving me the, yes, the soft delete retention day. So for how long should the key vault keep secrets, keys, and certificates that have been deleted? The default is 7 days, just because it's a demo here. I stick with 7 days, so we don't need to specify that if we stick to the default. But in a real world example, you want to have at least 30 days or so, depending on what your company is demanding there. And finally, the SKU, the SKU name, and That's pretty easy in terms of the key vault. It's always standard as long as you don't want to have dedicated hardware modules to secure your secrets. We don't need that. Haven't encountered any requirement by any company to have that until now. Certainly there are use cases. Quick formatting. Next is the actual key. We only have one here. We could have multiple. I'm naming this one ACR encrypt key as a resource, and then the display name ACR key. Since it only uses one, it's clear that it's used to encrypt the registry. Obviously, it should be known where the key is coming from. So we have to provide the key vault ID. And since we are creating the key vault here, we can reference it directly and don't need to go via a variable. And here it's simply the ID. Oftentimes it is necessary to have a expiration date for your secret certificates and keys. So we're going to set that here. The only thing that's a bit inconvenient, the date format is quite tricky. That's why I'm copying it here to not have to type it. And that very short duration time here is fine for me. I'm in February 23, and by then this key will expire, and either you have auto rotation in place, which is really expensive, by the way. It's per secret priced. Or you have set up a process to more or less manually or through your pipeline provide new secrets. And then regarding the key itself, we need the key size and the key type. For a size, there will be some requirement given to you. I'm picking 2048 here, and then the key type, which encryption type it should be using. I'm picking ASA. That's good for me. Format. And then you already saw the key options. And this is a collection of operations that the key can perform. Let's get rid of these. Okay, here things like wrap, unwrap, sign, verify, and so on go into, and you have to write them as individual strings, comma separated. I will do that real quick. So there you have it. Some operations that are allowed for that key with that expiration date and this encryption mechanism. Okay, now to the private endpoint configuration. It consists of three parts: the DNS zone, a CNAME record, and the endpoint resource itself, which is this one. Let's start with the private DNS zone. It lives in a resource group, and other than that, it only has a name attribute. But this one is actually really specific, and it's specific for every PaaS service that you want to establish a private endpoint for. So you have to go to the Microsoft documentation and get the exact name as a string. I'm going to paste it in here and also provide a link to the Microsoft documentation where you basically have to get it. It's this one here, Microsoft Learn, under Azure Private Link, Private Endpoints, DNS, and there for every service here, there's Vault Core. In case of the storage account, it's something called blob for the blob service, then table for the table service, and so on. Although I'm not sure if there is private endpoint capability for every storage service, but for files and for blob, there should be. So look it up for the specific resource that you want to use your private endpoint. Let's just quickly head over to MySQL. Here it is private link mysql.database. And for the storage account, I'm using a blob service here. It is blob core. Yeah. And obviously, there are many, many others. But that's it. That's it for the private DNS zone. Going over to the CNAME record. It has some name, but actually in this case, the name doesn't matter. You can choose it totally random. It's in a resource group, obviously. It has a reference to the DNS zone, of course, the zone name, so we can reference that directly. It is this one here, and it wants the name, so should be that one. Yes. Oh, okay. Then the actual senior record is specified via the record attribute. And here I like to include the project name. Of course, that's not needed, but I do it in this case. Project name and maybe Key Vault, and then the ending is actually given Vault Azure.net. So basically the suffix at the end should match what type of service you want to connect. But in the beginning of that record, the prefix, let's say, you're free to use whatever you want. And a time to live, let's say 1 minute here, 3600. Format it real quick. And that's the CNAME record done. Lastly, for the private endpoint connection, the actual private endpoint resource itself, give it some name, doesn't matter here. It has a location, a resource group, and a subnet ID. A private endpoint always, always, always lives in a subnet. So I have a dedicated subnet already set up, and I'm referencing it here. And then it has two blocks, private DNS zone group and private service connection. Within the private DNS zone group, we specify a name that is again random, but we have to have it. Let's call it keyword zone group. I'll make it shorter. Okay, that should do. But obviously, yeah, it needs the ID of the private DNS zone where it will live in. And watch out here, every time it says IDs with an S in the end, it means it wants a list. So put it into brackets, and then we can reference our private DNS zone that we created. And we called ours private endpoint pep DNS zone, and of that we want the ID. Okay, that's it for the private DNS zone group. Now the connection block. This one also takes a name. Hey, why is, okay, it is, before the auto completion isn't working. Here again, I will use the project name. And then keyword dash private service connection. Then it wants a resource ID for the private connection. And that is going to be our keyword. Maybe a bit counterintuitive private connection resource ID, but it wants the, oops, the keyword, and don't forget the ID in the end. Then very important point here, the sub-resource names. This is again something that you have to look up. It has to be exactly what Microsoft wants you to put here, and in our case it is Vault. Let's quickly jump over to the storage account. Here it was blob, and what was the other thing? The database also has one. And here it is MySQL Server, so very specific names that you have to provide there. And lastly, a Boolean is manual connection, true or false. You're going to set that to false here. Save, format, and that is the private endpoint connection done. And lastly, for a very basic Key Vault monitoring, we're using a diagnostic setting, which is going to push audit logs into the storage account that already exists. This resource takes obviously the storage account ID and the ID from the key vault, just to know, yeah, what resource should be targeted here. So storage account ID, we have to use a variable here because the storage account is not within the same module, but in another one. Well, it's already here, storage account ID. Already prepared that. And the other point was the target resource ID, what resource is actually providing the logs. And that is our key vault that we have set up here. So we can directly reference it. And don't forget the ID in the end. Having done that, we have to tell the resource what to log, or even if you want, what metrics to use. But in our case, we're just going to do a log block here. And there we have to specify a category. And in our case, this is audit event for every login and access to the key vault. And we have to enable it. And that's it basically for the key vault main file. And very quickly, like with the container registry, let's have a look at the outputs file. I'm putting out the ID of the container registry key or the key used for the container registry. And from the keyboard itself, it certainly would be good practice to also output the names. I just stick to the bare minimum here. And in the variables file, we have location resource group project name, the tenant ID from our Azure AD tenant for the key vault, the subnet ID for the private endpoint to be placed in, and our storage account ID that we used for the analytics settings, or no, sorry, what are they called? Diagnostic settings, right? Okay, now that we think we are done with the key vault and container registry configuration, let's head over to the main file on the project level. Let me collapse that. So within the modules, I have lots of main files. Obviously, I've seen people naming these main files like Kubernetes or container registry.tf. Doesn't matter. I stick to main variables and output. And then on the project level, I again have a main file that we are now going to use to write our module blocks for Key Vault and the container registry. I already have the block in place, but there are some things missing. And what I like to do at this point is just use Terraform validate to show me what is missing in my main file. I mean, right now there will be lots of things missing, so maybe it's not that easy to read, but it basically is saying me for everything that is missing, hey, in your main file on line 48 within the module key vault, the argument project name is required, but I can't find it here. And yeah, we use the project name within the key vault module, so we have to provide it here. There it is. And we use the variable for that we again will use in the variables file on the project level. So I'm just referencing that here. Basically the same as in Azure modules in this case. Okay, done. Next is the tenant ID, which is missing in the key vault resource. And that again has to be a variable, good candidate for an environment variable. Done. And I think there must be something else missing. The subnet ID should also be required, right? Because we're having a private endpoint. Key Vault subnet ID, and the search account, okay. And for the subnet ID, I can now reference the module with the subnets. I unfortunately named the, I know it's dependencies are the resource groups. Network is what my VNet is called. And here we have it. I think I'm going to use the endpoint subnet ID here. There's a management subnet ID and then AKS subnet. Going to use this one. No, it's already the ID, so that is fine. And then the search account. Module, storage, and now it just shows me everything that I have as an output in the storage module. And I do have the storage account ID as an output, so I'm going to use that. Okay, I think we're fine regarding the key. Okay, then next module is the ACR. We need the ID of the key to encrypt, and that we can get from the module Key Vault. And here it's the ACR key ID because it's explicitly the key ID, not the key vault. Then the keyword itself. Again, module Key Vault, and now the Key Vault ID. Again, everything you see in that context menu or in that IntelliSense popping up is what you specified in the outputs file of that module. Very nice. And project name is used as well. Okay. That was and is a variable. No resource that has been created anywhere. And do we have something else? No, these are always shown. These are standards. Okay, let's run Terraform validate again. No, it comes with more stuff. An argument enable is not expected here. Did you mean enabled? Okay, so we have a typo in modules keyword main. Okay, let's change that to enabled, save, and run again, Terraform validate. Okay, from this line on, now we're approaching the encryption type in the ACR module where I generously said we don't need these square brackets, and it was probably wrong. Okay, over to the main file of the ACR once again, and let's take a look at the encryption block. So Terraform validate says it has to be a list, and within that list can be one or more objects. We have one. Now it's a list again. Let's run Terraform validate again, and now it says it's okay. Okay. I'd say Terraform validate isn't perfect in the sense that it guarantees you a smooth apply, but certainly everything it points out is really wrong. So it might not catch everything, but that seems to be a clear one here. I thought I didn't have it like that before, but whatever, we go with it. And before we can try to apply, we have one more thing to do, and that is the role assignment for the AKS to use our container registry. To allow the AKS cluster to pull images from the Azure Container Registry, we need another role assignment. And I'd like to put that role assignment in the AKS cluster module, since this role assignment will be used by one of the AKS identities. So I prepared another role assignment resource down here, called it AKS ACR pull. That's also the name of the role. I'm going to go the easy way here and use the role definition name just because it's very short and precise. Again, you could construct the ID using your subscription / the subscription ID Microsoft.authorization role assignments and then the ID of the role assignment. But yeah, it does work like that as well. And then we need the scope, okay, and the principal ID. What identity is that role going to be assigned to? And here, for me at least, it was a bit hard to understand that it's not the ID or the managed identity of the API server. Up here, we have a identity in the Kubernetes cluster resource already specified. User assigned a identity. This identity needs the network contributor role to set up the cluster, to create that node pool resource group, but it's not the identity that's going to be used to access the container registry. That identity is the kubelet identity. It is mentioned in the Microsoft documentation regarding managed identities and AKS, but there is no example how to do it in Terraform. This role assignment that we are going to do is the same as you would do that AZ-AKS update with the flag attach ACR. It's creating a role assignment. So you can look at it in the, do it maybe via the AZ CLI command, look at it in the portal, and then do it by still, it wouldn't give you the specific Terraform code, but I can show you how it works. So we first reference our Kubernetes cluster, of course, but then we are not going to use the user assigned identity, but the kubelet identity. And here I think the auto-completion for the more or less first time, because it's not a question of have I gone down the line via the arrow keys or whatnot. In general, the auto-completion feature does work, but it's not providing the kubelet underscore identity. And it's since it's one specific identity and kubelet identity seems to be a list, we specifically say position 0, so the first one, and then the object ID of that kubelet identity, like that. And then for the scope, since we're in the AKS module, I can directly reference the ACR here, but oops, we need a variable for that, and we just call it ACR underscore ID, and that's it. Okay, format it, then save. And let's check in the main file whether we have that new property in the AKS module. Okay, and here we have it. It was commented out. And like that, it already should work. Reference in the module of the ACR, and there we have as an output the ACR ID. So that will work. Format that. Okay, because of the comment here, but actually we can delete that. We are not using the principal ID of the managed identity that is attached to the control plane or API server, because this identity is not used for attaching the ACR. And now we should be able to format that. Okay, save. And I'd say we have everything we need within the Terraform configuration. Let's do a Terraform validate again. Okay, it's still saying that an argument ACR ID is not expected here. That I think can only mean that it's not coming out the way we want it from the AKS module. Okay, and looks like we don't have the variable just yet. Or is it? It is here commented out. Okay. Save, run again. Okay, Terraform validation goes through, and now I think it's time to approach apply. I have one variable environment where I didn't set a value or have it in my environment variables. It will only accept test, prod, and dev, I'd say. Let's take test here, and off we go. Okay, the apply command is ready. It took some time because I forgot that I stopped the AKS cluster and the database servers. As you do that, then the state refreshing will fail, but I was able to start them just in time before the Terraform timed out. So we type yes, and hopefully this won't take too long because normally only the AKS cluster in that specific setup here takes about 5 minutes or so. Everything else here should be quite fast. Okay, the apply ran for quite some time since the Key Vault took over a minute and the private endpoint construction took also some time. But we got two errors here. One regarding the role assignment within the ACR module and another one connected to the AKS module and its node pool, although we actually haven't changed that. But we'll look into that later. But first, let's try to debug the error regarding the role assignment. When we did the role assignment or the identity block of the container registry and specified in the encryption block that a identity is used to get the key from the key vault, I said that it could be a place for it depends on, but it should be Terraform should figure it out itself. That first we need the role assignment on the ACR user assigned identity, and then we can use it to get the key from the key vault. So now it failed. Let's just try the depends on block here. And what do we need to specify? It should depend on the role assignments. And I think that's already it for the depends on block. Quick Terraform validate. That looks good. Okay, I will run the apply again and see if that error has been solved. And then we tackle the other one. Okay, I thought that would be quicker. That's why I let it run through, but I hopefully found a way to speed it up a bit. So yeah, weirdly enough, the AKS related error that we got up here is gone too. Honestly, where was it? Is that already the other cycle? No, it was here regarding the default node pool. Very strange, didn't touch it. Maybe it got confused because of the error before that. So seems like we fixed the error regarding the role assignment with the depends on block. Not so nice. I thought it wouldn't be necessary to do that, but yeah, it ran through and now apply is complete, and we will test our setup with a demo application from Microsoft and see if we can push and push the image from our local environment to the registry, then let AKS pull it from the ACR and check whether the container registry is encrypted. Quick look at the portal after the apply. We have our resource group here, where now the key vault is deployed, as is the container registry. And within the container registry, we see our encryption key here from our ACR or from our Terraform demo key vault, the ACR key, and it is used to encrypt that container registry and its images. Right now, there's nothing in it. That's what we're going to do next. To see if our AKS can use the container registry, I'm going to deploy a demo app provided by Microsoft, the voting app, or cats and dogs, it's sometimes called, where you have a simple counter where you can vote for cats or dogs. We will see it shortly. I already specified my container registry in here so that that YAML will pull from the correct container registry. You need a Docker daemon running. I here on my private laptop have Docker desktop running. It's a Windows system. But yeah, that needs to be running. And then we are logging into the ACR. Oops. I already have the name of my ACR here. Just log in. Takes a second. Okay, once we're in, then I already tagged the image so I can push right away. Docker push, and there is my tagged image. This actually takes 2 or 3 minutes or so. I'll be back once that is done. Okay, so the upload or image push is done. Let's quickly look at it in the portal. Here's our container registry. We already did look at the encryption, and here under repositories is our Azure Vault front in the version we tagged. Okay, let's update it today. Perfect. Now let's pull the image from the AKS, aka deploy the application, and see if that works. And for that, I'm going to get the AKS credentials, AZ, AKS, oops, get credentials. Okay. Um, and then deploy the YAML file that is provided with the project. kubectl, apply, F, and there already is our Azure Vault all-in-one Redis YAML. That looks good. Then kubectl get puts. And there they are running. Okay, that went fast. Usually it takes some seconds, at least for the front end, to allocate an external IP, which is that one. Copy that, head over to the browser, paste that in, and we should see our demo application. Wow, that took a long time, but there it is, a simple thing where you can vote cats or dogs and reset. And yeah, that's it basically. Quick look at the AKS cluster and its workloads. Under pods, we should see at the very bottom the Azure Vault front and back, healthy and running since 1 minute ago. And yeah, that's basically it. Okay, after having completed the configuration and testing our little application, some final thoughts. Please keep in mind that when you're using Terraform destroy, it won't be able to delete the key vault and the key because they are protected by purge protection and soft delete. Use the portal or the Azure CLI if you need to delete them. And if you're planning to come back to your Terraform configuration, please make use of Terraform state rm to delete the key vault and probably also the remaining resource group to have a clean Terraform state file when you're reapproaching that infrastructure demo. One more thing regarding private endpoint. Of course, you can also protect the container registry or restrict access to the container registry by making use of a private endpoint connection. I haven't done it here, but it's basically the same approach as with the key vault. It has that feature enabled and it is there for you to use. The next step now would probably be to build out the pipeline automation for our infrastructure and shift the service principal that we use to run the Terraform commands into a build agent or runner on a VM hosted within the same VNet that our application is going to live in, and to further restrict access to that VNet and its resources. But if you have any questions regarding what has been shown in this video, please let me know. Also, if you think that I could have done some things better, more efficiently, please let me know. I'm making this video and probably upcoming videos only because I want to solidify my learning, improve in the use of this technology. So any remark, comments, tip is highly welcome. And if you worked through a project lately that you've learned a lot, then yeah, please consider making a tutorial too. So thank you everybody for watching and hopefully till next time. Bye.